This is about how crowded I expected the analytics talk to be, but I know this will be the best, nerdiest crowd. So obviously I'm here to talk about open source analytics. I work for Dune, the crypto analytics company, unfortunately not the Denis Villeneuve adaptation. I work on the external data engineering team, so kind of our open source pipeline process. I've been in data science for about 7 years now, mostly like very practical ML, so consumer-facing data products like recommendations, trending, related feeds. My title is definitely a misnomer. I don't actually do a lot of data science at Dune. Mostly I'm leveraging my experience in the data science community to build tools for data scientists, which is a thing that I found out that I really like. So this is going to be a real quick talk. So I'm going to kind of quickly go through. We're going to talk about what Dune is, and more importantly, what the Spice is, what it was like to be a data scientist in the Web 2 world, something that maybe some of you are pretty aware about, why Web3 data is so much more interesting, why us data scientists and data analysts got to stick together and work together, and how we can do that. So Dune, and more importantly, the Spice. The Spice is Web3 data, not just raw blockchain data, but also decoded data and transformed data. Dune is a freemium analytics platform that our users, which we call wizards because they are magical, use to access blockchain data, write queries, fork other people's queries, create dashboards, share charts, and then generally like show off all their amazing work to the world. If they don't want to show off their amazing work to the world, it is private and it is paid, so that is kind of where the freemium component comes from. The dashboard on screen right now was created by one of our co-founders, Frederick Haga. Now, Frederick is a really smart guy, and he created this overview of DEXs, this like sector-level overview. Now, he's really smart, but he's an economist, he's a CEO, he's an expert swag creator, but he's not an engineer. He's not a data scientist. He's a burgeoning data analyst. So the question is, how can he create something like this? And the answer is open source analytics. So he made this dashboard out of maybe 10 lines of code, but there's thousands of lines of code underneath this and lots of expertise that has gone into understanding the smart contracts, validating the data, and creating dex.trades, which is this really important table that we have that allows people like Frederick, very busy CEOs, to come in and do this in-depth like sector-level analysis with much less time than it would normally require. So how does our platform work? How does the Spice flow? Dune is harvesting data from node providers using Kotlin pipelines, and then ingesting that into a Spark cluster. One of the biggest negs I heard about blockchain before I joined, it was just the world's slowest database, and that is true, and that's why we need Spark. We need fast databases to do our analytics workloads. So we're transforming our raw row entry data into our fancy Parquet columnar format, and then at the next step, we're decoding our data. So we're using the API to decode these smart contracts, and instead of just having a bunch of raw transactions, what we're going to have is your protocol and your function or your call as a table itself, which makes things much easier to work with. And the next layer on top of that is what I work on most closely, which is our DBT project, data build, where subject matter experts, protocol builders, general data nerds come in and build new transformations on the data, like dex.trades, like nft.trades, that make it super easy for about anyone to go in and learn what they want to learn about the sector. And then the wizards do their thing. They come in, they build their dashboards, they query stuff, generally speaking, illuminate the blockchain world to everyone. So these are some dashboards that were very topical at the time that I made this slide, but our world moves really fast, so maybe they're not as topical now. But we've got a slide on Tornado Cash right about the time that the Fed sanctioned them, showing inflows and outflows into the network. Since then, a group of wizards at ETH Berlin have done some really interesting work on understanding how there are ways that you can very easily dox yourself by using Tornado Cash. So they did a little bit of white hat sleuthing to kind of explain to people how to use this product safely. We also have institutional researchers doing their investment research on Dune, looking into curve finance. We've got people teaching themselves how to code, doing 100 days of code, and like learning SQL on our platform. And then also kind of like a topic du jour at the time I made this slide, looking at BinDAO and kind of the potential red flags in using NFTs as financial instruments. So the reason why I think this is so interesting is this stuff is like not possible on Web 2. These people don't work for the protocols. They don't work for those companies. Just in the last year, like I was really interested in like the home buying scandal at Zillow, and I was really interested in seeing like Peloton implode because I'm a big fan of them. But if I wanted to go in and build a dashboard of like where Zillow bought their homes and at what price, that's like obviously not possible. I don't work there. I obviously can't go in and look at Peloton's like bike sales projections. Like it's just like not a thing that you can do. And you can't do that because they don't have spice. They have oil. Data is oil in the Web3 world. And if you want to work with oil, you have to work for the refinery. This is from the Economist's 2017 article where they were the first people to make this analogy that data is oil. And you can see that all of these huge behemoth companies are still like huge companies. And if you're a data scientist in Web 2, what that means is you actually have like a really limited number of places that you can go where you have interesting data, you have enough data, and you have interesting problems to work on. And that, for me, I think is a really big bummer because, like, say you wanted to work for VIA because you like really liked those engineers and you really liked those people. As a data scientist, it would be a huge mistake for you to go there because Uber just had so much more data that you really had no shot. And the other problem is once you get into these large companies, you don't even necessarily have access to all of their data. You also don't necessarily have permission to share it with anyone else. In fact, you certainly don't. And the other problem is, like, you're always running around asking people to track things, and they say, next quarter, and you're like, please, just put the pixel in. And that's really not a problem for us in Web3. But the big issue, though, is, like, what if you aren't a big company gal or guy, and you want to work for a startup? Well, by definition, startups are starting up, which means they don't have the data for you. So you're going to come in and you want to build interesting models or do analyses, but really what you're going to do is sit down and build data infrastructure. And you're going to start collecting data, and then you're going to start hiring a team, and eventually that team will do the interesting work that you wanted to do. And that's really like the happiest case. Like the most common case is you're going to get frustrated and you're going to quit. So that's why Web3 data is this revolution now that we're working on this like public ledger. Theoretically, you can be at a two-person startup and have the exact same data access that mama tier companies have. And that's really for 4 reasons. When we compare like Spice, our Web3 data, and Oil, our Web2 data, we've got 4 primary differences. The availability, like I can go look at whatever like public protocol that I want to look at, so it's very, very available to us. It's extremely actionable, so if you have some negative information about a private company that they're about to blow up or they're imploding, there really isn't that much you can do. There are secondary options markets, but they're extremely illiquid. But in the Web3 world, like I can say, join that person's DAO or start staking on it or buy some tokens. So it's much more actionable for us. The data is much more connected. People have been, I think, relatively good about adopting these things like ERC standards, so it's much easier to connect your data together. And obviously, from what we saw on Frederick's dashboard earlier, the scale has gotten pretty impressive. So that kind of brings me to like why we should work together. You might have noticed from 2 slides ago, I said theoretically the 2-person company has the same access to data, and that's because you actually still have to build tons and tons of data infrastructure in order to access and utilize that data. And that can be very time-consuming and resource-intensive work. I also think that maybe it's not like the work that's the most exciting to us. So I think it kind of wastes a lot of human potential and a lot of time if we all duplicate the exact same infrastructure. And that's why I think it makes sense kind of like to start centralizing a little bit some of that work so that you can focus on the stuff that's actually interesting to you. So that's one of the things that we work on a lot at Dune. And I think this is kind of just the tip of the iceberg, but one of the projects that's really important to me is our public GitHub data build project, Spellbook. And this is an open source project where wizards come and work on new data transformations like NFT.trades, like DEX.trades. And this kind of allows everyone up the stack to have an easier time accessing and working with data. So this is a really interesting project because we have actual protocol developers coming and writing their spells to explain what's happening in their protocol. We have like really passionate people that work on this all the time. Like I would say I like work with wizards almost more frequently than my actual teammates. And it's cool because we can build cross-chain tables. They're completely transparent data pipelines. It's really easy to build community buy-in when you have specialists looking at your code. And we're able to follow really rigorous data quality standards. So one of the problems with SQL is it's really hard to test. And dbt is a tool that makes that a lot easier for us. And it does that by allowing us to kind of steal a lot of the best practices from software engineering and bring them back into analytics engineering. A nice thing that it also gives us is dependency graphs, so you can really easily visualize like a really complicated DAG and see what data and what models are actually going into your end table or view. We have nice like separation of development spaces, so everyone can kind of work on the same models without running into each other because they have these personalized namespaces. You can actually write unit tests against your SQL, both kind of like really easy checks like checking for nulls and uniquenesses, but we also frequently go into our own wallets, calculate out what the value should be for like 3 or 4 different rows, and then write our tests against that. So we're actually doing test-driven development in SQL development, which I think is cool. Preventing regressions and our data quality. And then the nice thing is also you can write UDFs and macros and for loops, so you're no longer like repeating the same thing over and over and over again. So that's my pitch. I'm assuming you guys are vaguely interested in data. If you chose to come to this talk, I would love for you to join us on this. Here are a couple of useful links to our public repo, to our Discord. Everyone is super nice and willing to help. Go to our site, Dune.com. We spent a lot of money on it. Please find me on Twitter at @Surat or on Dune Analytics. And thank you so much.